Good morning, and today we will do some non-linear problem using by that means Matlab for optimizing problem. If you remember the last class, there the all the constant whatever we have seen there that was the linear, right? Now today I will tell you about how we can that means use this Matlab for solving non that means linear problem. So let's see what was the nonlinear problem. This was the nonlinear problem. If you see that the constant it is nonlinear, optimization is nonlinear. If you see that this is nonlinear, right? And this subjected to these are two constant G1 and G2, and this G1 and G2 we say inequality constant, and H1 and H2, and these are that means equality constant. But if you see that in G1 and H2, these two sorry G2 and H2, these two are non-linear, right? How we can handle with the MATLAB? Okay, let's do first of all graphical approach. From the graphical approach, whether we can get the that means idea where will be the that means local minima, or I should say that minima that means minima function will be occurring, or 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 we can say that with all four constant along with this x1 and x2, this two variable problem, what should be the feasible region. So let's first of all we can see how we can write the code. If you see it, the x1 and x2 I am telling that is, you see the problem here, x1 and x2 are two variable and the minimum function will be these things. You can see the x1 plus sorry minus 3 plus x2 minus 2 whole square. Again I am telling the function, that means this is the circular counter that means uh, problem, that means minimize function x1 minus 3 whole square plus x2 minus 2 whole square, and we know the center will be at plus 3 and plus 2. Now the subjected of these things, so this is the code I have written here. If you see that, so now the first that means if you see that inequality condition, it is here, that is x1 plus x2 is less than 7, that is x1 x2 less than 7. So let's see if I run these things here. So this is the feasible. If you see that x1 greater than, that means this is the situation, x2 greater than, this is the situation, right? Now the first constant here, the g1, that is this is less than, that means this is the feasible region till now. The now till now, the now the next will be, this is the less than, now the next will be, if I run here, I should click here, again I am running. This is your I am talking about, this is your g 1, so I can write here g1, this is your g2. So you can see here the next is here g2, this is the function, and equal to, that is 0, that is this is the function, that is less than and equal to 0. That means I can say this is g2, yeah, and this one will be the h1. You can see this one will be the h1, that is the equality sign. This one will be the h1, this will be the h1, that is equality sign, equal, right? And this is equal to 8 2x, this is equal to 8. So I have this function, that is your h1. So right now the feasible region, if I say from the g1 g2 and h1, that will be the this this one and this one, and till here this one is the region, right? If I say, if I have only G1 and G2, then the feasible region will be, if you see that the feasible region will be from 0 to here and here. Now I have one more function, that is equality, that means h1. That means the minima will be occurring on this line. That is the first thing. Now this is the h2, right? This is the h2, this is the h2. So now the function it is calculating here. That means if you see here, the minima definitely occurring at the h1 and h2, the line where it is crossing it, that things, right? And along with these two constant we have, so this is the things here, right? And this, if you click little bit bigger, so this is the minima occurring, right? You can see this is the minima, here it is occurring. So what will be the value? That is 1 and 6. And what will be the value? If you see that the green line, that is, it is 20, it is 20, right? It is 20. So that means, and if you see that this curve center, this is curve center is 3 and 2, that it was a circular, it is a circular contour curve. If you see that, this is the first, if I say this is the second curve, third curve, and so on. But what will be the best solution from graphical method? You can see it here. That's right. So this is the way to do this problem with the help of graphical approach. You can see already you have written all these things, right? You can change these things till let's see till 40. That means this counter will be till 40. This will not go to beyond this thing. This will not be showing. Let's run it again. You can see it. The function, this was the G1. So I can click here the G1. This is your G2. So I can click here G2. Right. This is H1. This is H1. This is H2. I can click here H2. And this is the function. It is showing elliptical, but actually it is circular. Why it is showing elliptical? Due to this aspect ratio. This x1 is the this, you can see that this much, and x2 will be this much. That the aspect ratio is not same. You have to keep the aspect ratio same there. By this way, x is equal. Once the program will come here, then automatically it will that means it will show you circular contour. Let's do. Now it is, see here that the minimum is here. Now our code is fully run. Now this is the circular. Now it is showing that, right? Here is the minima appearing. What I wanted to say you. Let's do by some inbuilt function. So right now I have, this is your objective function, x1 minus 3 whole square plus x2 minus 2 whole square. This is objective function. Let's see initially guess. This is your initial guess, right? This is your initial guess. Now the function I am using, f mean con. So you can see how we can write. You can take help from Matlab documents, and it is beautifully it is written. You can see here everything, the such that this is the first, that means G1, this is your H1, and from G1 and H1 I can write in this form, and this is the upper limit and lower limit, right? Now these are the syntax. We can write it, the way to write it, this is the syntax. This is the syntax, right? Now if you see here, everything it is written here. The x1 is the initial guess point, initial x point, right? Objective function, inequality, hb, and all these things are written here. So I suggest you should go all the things so that you can understand in better way. So once I am writing here, you can see the a. So what is your a? If I say, you can say this a is, right now I have only linear equation which is inequality, that means x1 plus x2 which is less than 7. That is one coefficient and one coefficient, and b will be vector, that is here 7. So that means 1 1 and 7 I have written here. So if you see about this one, that means this h1 that means equality. This is your equality. You could see that this is 2, this is 2, this is 1 here coefficient, this is 1, and this is your 8, right? This is your 8. So I wrote it. Now what about this non-linear constant? So I write this function, these two function in this form here. So this is your function, non-linear function, that is c1. You can see that means here it is in the problem, it is g. So this is the constant, another will be, this is the constant, you can see here, right? These two are the constant I am writing here. Now I need to that means run this code, right? So let's run this code. You can see here it is showing that x1 is 1 and x2 is that means this is 6 and the value is 20. If this is the 20, you can see the way that is 1 and 6 and this is 20. The same thing I got from the that means from the code also. So let's use how I can use, that means optimization tool. So that means the first two I have seen, that the first one was the that means graphical approach, second was the with the help of that means code and inbuilt function which is inside the Matlab library. I use it. And now the optimization tool, so I can write here optimize tool. It will go to the directly to the optimization tool pop-up, and here we need to write it. Here we need to write it. So that means you need to write it f minimum constant. Now here you have to write this at the rate. What at the rate? At the rate you have to see it. What was the function? This is the function, you can see. We have to write this function, and the function name itself is a function. The problem was on kkt. So this is the function I've written, and you need to here copy and paste here, right? The starting point already you have seen that 1 comma 5. What is a? Already you know that a is 1 comma a, and b was the 7. I think I have to relook 1 1 and 7, right? And what about this g and g2 and h2? This is nonlinear, so you have to supply here nonlinear constant. What about this one equality? This is 2 1, that is 2 1, and another will be here I think 8. Again I have to see it. No, it is, yeah, it is 8, right? So now the non-linear I have to write the, yeah, first is upper lower and x1 and x2. This is the upper lower level of x1 and x2. Upper level x1 I made 10, and this is 10 I am saying, right? Now what was the function I write here? This non-linear function in this form c1 c2 I have, that means g2 and h2, and this is the function. The name itself is a this function. I can copy it, right? nlcon. So I can write here nlcon. Yeah. So let's run it. Everything is clear. Let's run it. After 25 iteration, I am getting answer is x is equal to 1 and x1 is equal to 1 and x2 is equal to 2. And what is the minimum? You can see it is a 20, and you can see local minimum possible, right, and constant satisfied. That is the most important point you have to see in the result. So let's see how criteria, that means the function, all these things I am taking by default. You can supply your criteria also. Hessian, already I have told that what is the role of Hessian. Let's see plot. I can see the value and the maximum maximum constant, right? And how many iteration, that also it will come. Okay, now all clear. Now run it. You can see how it is. Yeah, at initial, if you see that at x, that means at this 1 and 5, the function value it is giving this one, right? But error was, you can see that the error was, that is violating here. So again it is doing the iteration. After few iteration, I am getting almost it is, you can see that is, this is, we say, every time it is, that means going to the right direction. Okay, constant, you can say that going also, that means initially it was this much violation, now it is zero violation, right? Okay, so the things here, if you see that the x1 is here 1 and x2 is here 6, and you can see here, and you can see here what was the result. You can see here, after how many iteration, after 25 iteration, we are getting this answer, right? So this is the way to do this type of problem. Okay, so I always say you try it. Once you try it, you will learn. So this is the way to do this type of nonlinear problem. Again I will post some, that means problem, how we can solve this all type of, that means engineering problem, the engineering optimization problem using by, that means Matlab, even I can say graphical method, Matlab, that is inbuilt function, and Matlab tool. So all three will give you, that means the, that means figure, that means you can, that means correlate between these three two, so you can better way understand the things. You play with the software, you will learn. Once you play the software, definitely you will be learning. So that is my today class. Now the things here, you practice it. I will send you some more problem, you can practice it, then you will be confident by using this software. Okay, that's okay.